Good day. Today we want to consider angle 45 degree, one of the special angles we've been obtaining the values so far. For an angle 45 degree, you need a square of side 1 unit each. Suppose you have this square, let us assume this is a square of side 1 unit each. This is 1, this is 1, this is 1 unit, and this is 1 unit. And therefore a square, all the angles, each of the angles, interior angles, is 90 degrees. So the interior angles, each of them is 90 degrees. So you can bisect the square along any of the diagonals. You can bisect it along any of the diagonals to obtain two right-angled triangles. So between the two right-angled triangles, let us pick one. Let's assume we pick this, so which is the right-angled triangle. If we pick this as the right-angled triangle, don't forget this is side 1, this is side 1, this is 90, this side is 90, and this side will be 45 degrees. This side will be 45 degrees. This side is the longest side, so it is the hypotenuse side. It is the hypotenuse side. This side is 45. This angle is 45 degrees, and is facing this side 1. This side 1 is opposite to it, so definitely this is the opposite side, and then automatically this becomes the adjacent. This becomes the adjacent. So we know the value for adjacent, the value for opposite, but we don't know the value for the hypotenuse side. So we can quickly apply Pythagorean theorem. We can apply our Pythagorean theorem to obtain that. The hypotenuse side, let's name it as h. So according to Pythagoras, so the square of the hypotenuse side is equal to sum of the squares of the other sides. So the other sides are 1 square plus 1 square. So h is going to be square root of 2. So we can then say that our hypotenuse side is root 2. The hypotenuse side is root 2. So with this one, we can go ahead now to obtain the 6 tree functions of this angle 45 degrees. So beginning with sine 45 degrees, sine 45 degrees, which is sine 45 degrees is opposite over hypotenuse. Opposite here from the diagram, the opposite side is 1 and the hypotenuse side is 2. So it's going to be 1 over root 2. 1 over root 2. And never leave a square root sign as your denominator. So we perform the rationalization. Root 2 multiplied by root 2, and that gives us root 2 over 2. Then we move on to cosine 45 degrees. Cosine 45 degrees. So cos 45 degrees, which is adjacent over hypotenuse. Adjacent over hypotenuse. And that is 1. The adjacent side from the diagram is 1. The hypotenuse side is root 2. So that will be 1 over root 2. Just the way we obtained the one for cosine 45 degrees. So we also obtain root 2 over 2. Then we have the tan 45 degrees. Tan 45 degrees, that's opposite over adjacent. Opposite over adjacent from the diagram. Opposite is 1, adjacent is 1, and that will be 1 over 1, which is 1. And then the reciprocal functions now. Cosecant 45 degrees. Cosecant 45 degrees, that's 1 over sine 45 degrees. Don't forget our sine 45 degrees is 1 over root 2. So that will be 1 over root 2. And that gives us root 2. The same thing with secant 45 degree, which is 1 over cosine 45 degrees. So we have that one as 1 over cosine 45 degrees is 1 over root 2. So 1 over root 2, which is root 2, and then finally we have cotangent 45 degrees, which is 1 over tan 45 degrees. Tan 45 degrees, we got that as 1, and then that will be 1 over 1, which is 1. Thank you.